Guys, in this video, I'm going to discuss the Codechef starters 134, the problem which I wasn't able to solve. 3out1in, prison escape, and chief victory. In this video, I will cover the 3out1in. So let's get into the video. So basically, if you read the problem statement, it's quite easy to understand. Anyways, I will read it for you and help you understand the problem statement. Then we'll go to the solution part. We are given an array B containing m, where m is the odd integers. You have to perform the following B operations until it consists of only single element. So basically, what it says is we are given an array B, and array B contains only odd number of elements containing where m is odd in containing m integers. Yeah, odd integers. Array size can be 1, 3, 5, and so on. And we need to perform some operations, like we need to choose three distinct integers I, j, k, and positions of I, j, and k doesn't matter. So, and it can be anything. I can be greater than j, or j can be less than k, like that. I, j, k. And after choosing the three distinct integers, I cannot, one constraint is that I cannot be equal to j cannot be equal to k. And after choosing three distinct integers, we need to remove all the three elements bi, bj, and bk from the array, and add one new element to the array, which is bi plus bj minus bk to the array. So yeah, so we are removing three elements, and we are adding one element. So basically, minus 3 plus 1 is 2. Overall, we are removing effectively two elements in each operation. So that's what is written here. Operation reduces the length of the array B by 2. So basically, for example, 2, 5, 3, 4, 2, we are choosing the indices 3, 1, and 4. 3, 1, and 4, which means B3, B1, and B4. So they made it's not as zero base indexing here, and B1, B2, B3, B4, and B5. And B3 is 3, plus b1 is 2, minus b4 is 4, which is 1. And we are removing the all the three elements b3, 3, 2, and 4, and adding this new element to the end of the array 1. Okay. And new elements are always added at the end of the array. Your aim is to maximize the value b, value of the final element remaining in the array. Let's maximize the value. So basically, the problem states that we are adding one new element, right? In that, after performing all the operations, like each and every time, like removing the three element and adding one element, you will be finally resulted in the array with only one element that needs to be maximum value maximized. And number of operations you are going to perform, they haven't mentioned that, so you can perform any number of operation. Only thing we need to keep in mind is that the final element we are going to get after performing the operation should be maximum. And that's it. We can get into. And one more thing is that uh, they will be giving q queries. And queries, basically, if you go to the test case, I will help, it will be easy to understand. So basically, one is the test case number of test cases, and next is the n and q, which is the size of the array and the queries. And next comes the size, the elements of the array, and next comes the elements of the queries. So basically, queries element stands for you are going to perform the operation till from a first element till length of the query. So basically, see, this is the array length and this is the query. For each query, we need to get the maximum element. Like for query 3 here, we need to perform the operation from first element to the third element, and get the maximum value. What is the operation? Get three indices. That operation you can perform any number of times. Get the three indices, remove them, and add the new element bi plus bj minus bk, like that. And if the query is 1, get one in first element, so no need to perform any operation. This is the maximum element we can achieve. And if it is 5, which means you need to take the whole length of the array and then perform the operation. So basically the queries element represents the restricting the length of the array. Obviously the query elements will be less than or equal to the array length. So basically, you can pause the video and think how to solve, and I'll just quickly get into the video of the brute force approach, and then I'll tell you how to optimize it. So if you have a thought about how to solve it using the brute force, so basically what they are doing is choosing three indices and adding first and second index and subtracting the third index. So in bi plus bj minus bk, and where j can be after k, I mean jth position can be after k and kth position can be after I, it doesn't matter at all. So we just need to do bi plus bj minus bk. So if you see here, if I write it here, bi plus bj minus bk, what you need to do is basically for in everyone's mind, you will come to know that if the we need to sort the array, then only if we sort the array minus 1, 2, 3, 4, and 5, then only we can get it like maximum element. We are like basically if we need to maximize this one, what will we do? We will maximize this and we will minimize this, right? So if we take bi and bj as 4 and 5, and bk as, we'll keep this as a some separate array, and again here we'll minimize this whole bunch, right? So if we minimize this whole bk here, and this will be inside the sub of reverse, like it will be easy to understand. See, no, in the first iteration we just need to maximize, and in the next iteration it will be like once it goes inside the next bunch, it will be like minimizing this thing. Since we need to minimize the bk, so what will we do? We will take bi as minus 1, bj as 2, and bk as 3, and we will perform the operation minus 1 plus 2 will give you at minus bk, right? Minus 3. So minus 2. So minus 2, 4, and 5. So bi is 4, bj is 5, and bk is minus 2. So minus of minus bk will become plus, and overall this will be positive. So basically if you see that after sorting, just if we choose the first element as a bi and second element as bj, and consider the rest of the array to minimize the operation, like just the vice versa of the operation, no need to maximize it, just minimize the operation. Like instead of bi plus bj minus bk, just take the bi and bj as the minimum most element and bk as a maximum most element. You will get the minimum value and you can perform with the outer array. So in a brute force approach, you can do it using q. Yeah, but it will give you time limit exceeded or wrong answer, but it is necessary to understand the brute force approach. So what I did is I just removed the first three elements out of the array and added a new, like this. I just format the code, it will be easy to understand. Yeah, I just sorted the array at the first, and then if the size is not greater than 1, then I just print the first element of the array. If it is greater than 1, then choose the first two elements, separate the first two element as I said here, and remove it, and play with the remaining elements of the array and get the size of the array, and take the I as not the n minus 1. If the this is the new array, size is n, I should not be n minus 1, I should be the minimum most element. So n minus 3, j should be next second minimum most element, n minus 2, and k should be the largest element. Since we are reversing the operation, instead of maximizing we are going to minimize it, and each and every time we'll get the three elements and pop it back and add a new element. New value will be this thing, and again sort the arrays, as we will not know that new element can be less than or greater than. So we just need to again once again sort the array, and once it reaches the array value as one, then we can just get exit the loop and then perform it with the other operation like a plus b minus the value we got here, and push it back to the result and print the result. This is just the brute force approach. And what the problem here is, in each and every iteration I am sorting the array which is n log n operation. So it is now basically n log n plus n minus 2 log n minus 2 so on, and it's just basically n log n operation each and every time. So it will result in a wrong answer, a time limit exceeded. The basically the in order to sort, in order to solve this now problem, we came to know that sorting is the main concept in a brute force approach. And then optimization problem we can solve it using priority queue. So basically you can keep two priority queues, one for max heap, one for minimum heap. Basically, by definition, max heap and min heap, like max heap will is like a queue. Like both the priority queues are like not a queue. Sorry, both the priority queues are like a stack where the elements are getting added. And basically, what's the rule of the stack is last in first in method. The last element which entered into the stack will be the first element to be taken out. So max heap will have the largest most element in and at the top, and min heap will have the minimum most element at the top. So I have discussed the brute force approach, and yeah, in basically in other words, you can also see the test cases where if the test cases if constraints, if the n is 10 power 5 and q is n by 2, you should automatically get the idea that it cannot be solved using the brute force approach. And since we came to know that sorting is the one way to solve in the brute force approach, we can use the priority queue to reduce the log n log n to log n time operation. So after if you more invest some more time into the problem, you will find the trick that the problem can be easily achieved by just by finding the sum of n by 2 smallest element and n minus n by 2 greatest element and get the difference. That's it. So basically, if you see here, if n is 1, one for single element, so I mean if the k query length is k is 1, just give the element to the array. If k is 3, perform the operation. If k is 5, the whole array. See, n by 2 is 5 by 2 is 2. Get the sum of two smallest element and get the sum of three greatest element and get the difference. So you can also perform the operation as I said using the brute force approach, or else get the sum of three greatest element, get the sum of two smallest element and get the difference. That's it, you will get the answer as 11. And basically, in order to find the n by 2, it's like finding the median in the array in an unsorted array. Finding the median in the unsorted array. Either you can sort the array and find the median, and then you can do the binary search and then solve the problem. It is n log n. And you can use the priority queue as a min heap and max heap to solve it in a log n complexity. Similarly, yeah, basically if the same, like you just need to put a two condition if the max heap size and min heap size are equal, or else if it is not equal, get the top. And you can have this, as I told, right, you need to get the sum for n minus n by 2 greatest element, that will represent the max sum, and n by 2 smallest element, that will represent the minimum sum, and calculate the answer. And finally, get the difference of minimum sum minus maximum sum, or anything like if which one is ever greater, and you can get it. That's it. Thank you. Watch. Thanks for watching this video.